Lab 3, determining the mass of a black hole. The objective of this lab was to determine the mass of a black hole using given position data of a nearby star. We created a computational model based on Newton's second law in order to display the trajectory of the star around the black hole. The result of my lab was a mass of 3.58 e to the 31st for the mass of the black hole itself. In order to display the trajectory of the star around the black hole, we apply key physics principles such as momentum and change in velocity, as well as Fnet, to display and apply to our VPython. So to determine velocity, we determine that as change in position over change in time, and velocity, the change in velocity will equal final velocity minus initial, and we do this over the course of the data set we were given. The change in momentum will equal change in velocity times the mass of the star. Fnet will be represented as change in momentum over change in time. Fnet can be broken down into the parallel and perpendicular components, as well as dp/dt, which gives us the perpendicular and parallel components. The perpendicular component will give us the curving motion, while the parallel will give us the. In order to calculate for the mass of the black hole itself, we use the gravitational force formula, which is equal to g, the constant 6.67 e to the negative 11, times the mass of the star, times the black hole, mass of the black hole, all over r squared. So here is my VPython code. As you can see, I created an attribute for the black hole itself to visualize it, as well as the star, and created a radius to display it. And as we go down, I included the mass of the star as star.m, which is equal to 2.7615 e to the 27th, and also included the position that was given. I also included a black hole mass total, which I used to calculate the average mass and set a t-step. And also delta t was set as 86,400, which also represents 1 day, t being 0. Here we calculated the velocity for the x and y components using a while loop, and stored them in an array. Down here we calculate the Fnet. We have v initial, v final, p initial, p final, delta v, delta p, and simply in order to calculate these, we simply took the formulas and applied them to VPython code that it would be able to understand. dp/dt was set to delta p over delta t. Fnet, as we said, is equal to dp/dt. So in order to determine dp/dt parallel, we broke it down to p hat and d mag p/dt, and that we set to Fnet parallel. So in order to calculate dp/dt perpendicular, we subtracted parallel from dp/dt and set it equal to Fnet perpendicular. And here we created the star trail itself. We also set an arrow scale to visualize the forces. And down here we have the formula for the mass of the black hole. We simply rearrange the gravitational force formula, and down here we have the continuous loop for the average of the total mass. And we printed out the mass of the black hole and the total, which would be the total, the average, which would be the total minus the total time step. And also the Fnet parallel. Here we have the computational model. And that was a bit fast, but as you can see, we have a black arrow which represents the parallel component, and the blue and yellow which represent the Fnet and perpendicular components, all pointed towards these two would be pointed towards the black hole itself, which is right under these arrows. The star itself is right here. So it did display the trajectory. So the computational model did work. I did have some initial problems since I didn't include a partial part of the code, so I had to go back and do trial and error several times to get the code. Here we have the printout from the shell. So this will be T, this is Fnet parallel, Fnet perpendicular. So these two would total up to the Fnet. Here we have the mass of the black hole, which I checked on WebAssign to be accurate. Here is the total mass, or average total mass, which was quite close to the mass that was given. So now let us answer some questions. What does it mean? How are Fnet parallel Fnet perpendicular, different for DP/dt parallel, and perpendicular. DP/dt is an observation, or can be calculated from our observations, which in this case is the data set that was given to us. Fnet is the sum of the forces creating the motion of the star between the black hole and the star, so it cannot be calculated. Fnet is qualitative, while DP/dt is quantitative. Lastly, what if? Imagine a black hole whose mass you found was removed and a different black hole was placed in the same location. Assume the motion was unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? No, since the the motion remained unchanged, we would not be able to determine that this was a different black hole. So there you have it. This is my lab 3. Thank you.